We use several different ion beam systems here at Bristol. Ion beam analysis is a bit like sandblasting, but on an atomic scale. We fire a tightly controlled beam of ions, usually gallium, at the surface of a material. These ions cut away or etch the sample surface, allowing us to alter its shape and analyse the material that's been removed. Ion beam allows us also to manipulate materials on a nano to micro scale and make or shape small objects. We can even remove them from the sample using manipulator needles to use in other techniques. We can also make cross-sections into a sample surface using the ion beam and then image its structure and composition. Cross-sectioning is useful for things like semiconductor manufacture, alloy design, or measuring the thickness of corrosion layers. We've even used it to section the body parts of small insects to better understand how they hear and move. We offer two types of instrument here at Bristol: focused ion beam systems, which we call FIB, and secondary ion mass spectrometers, or SIMS. The focused ion beam, FIB, is used for high precision milling of samples, etching microscale trenches for subsurface analysis, or preparing ultra-thin foils for transmission electron microscopy, atom probe tomography, or other microscopy techniques. We can also look at cryogenically frozen samples where soft organic matter would otherwise be damaged, or to keep elements like hydrogen in place where it would otherwise be lost. At Bristol we have a standalone FIB system, as well as a dual beam instrument, which combines ion beam with electron microscopy, and that allows you to see what's changing on your sample as you mill it. We've used FIB in the past to look at pre-production computer chips and semiconductor devices before they go into mass manufacturing. The FIB has the capability to deposit tiny patches of platinum to glue things together or add conductive pathways, and clients have asked us to perform fault diagnosis or even repair of semiconductor devices. We have significant experience using this technique in the field of metallurgy to understand how the microstructure of an alloy changes when exposed to heat, loading, or corrosion. This allows our industrial partners to better predict the behaviour of their products and materials and to design better alloys in the future.
We've been involved with a number of projects here at the university using ion beam systems. The use of ion beam imaging allows us to characterise corrosion morphology on an extremely fine scale, and also to link microstructure to specific corrosion processes which can occur over very small phases of a surface. We've been really happy to use the facilities here, and we've worked really well with the team, so I'd certainly recommend other industrial partners to make use of them.
The second ion beam technique we use is secondary ion mass spectrometry, or SIMS. SIMS is useful for identifying the composition of samples and mapping differences in composition as a function of location and depth. The excellent detection limits of SIMS are really important in cases like the coating of printing paper, where the combination of chemicals used needs to absorb just the right amount of ink, but not to smear or bleed into the paper's fibres too much. Identifying the exact ratios of each elemental component is crucial to understanding the properties of many materials. Ion beam techniques offer your business huge potential to improve and develop your products and services in a wide range of sectors. So, to find out how we can help you with your application, please don't hesitate to get in touch.